Right then, welcome back to part 3, and today, as you can see, I'm in the lab, okay, and sitting in front of my CNC machine, we're going to be making a PCB today. Now then, on the screen, you can see that I've already imported my Gerber file that I'm going to make, okay, my PCB. It's basically it's just a little breakout board, just for some various surface mount components, etc. Just SOICs and whatever will fit onto that. And we're going to be making this board on the CNC, so I'll show you how to isolate it, set the tools, etc. and start milling. So, the first thing that we do, introduce you to the milling machine. Here we are. Okay, first thing that you need to know, okay, this is the Y direction, and this one is the X, okay, it's actually reversed from the standard, okay, so it's Y and X, okay, that follows through on the screen as well, so you don't have to get too confused. At the moment, milling heads all the way at the back, so we can place some material on the bed. And when you place material on the bed, you always do it down this centre line here, okay? So, if you've got a double-sided board, you can flip it on the centre, okay? So, flip it that way. And we're going to be making our board on this here. This is a single-sided FR4. Okay, now you don't mount the material directly onto the bed. Why? Because if you drill through, you're going to drill into the bed, okay? So, it's very important to use some of this stuff. This is backboard, okay, and you mount it using pins. You've got pins like this, okay, place the pin into the first one, into our origin, you place the backboard on, and you place your material. Now this one's already been pre-drilled. You've got a pin hole at the front, and a pin hole at the back. So we can slap that on top of our baseboard. That way when we're drilling through, we just drill through the PCB into this backboard, which is replaceable. And grab your other pin, okay. All you do is just line up the holes at the back, slide it through your sheet of material and into this bar. Now this board doesn't move at all, okay, so it's all aligned to the centre. Okay, so we've got our centre line, our imaginary line going right way down the middle. Masking tape, always use a bit of masking tape just to hold the board in place, just in case it does spring up. So, make sure that you tape it down. Don't tape it to the backboard in case the backboard shifts. Okay, always make sure that you tape it down to the bed. The worst thing that you want to do is for this material to actually spring up, catch on the tools or on the milling foot and do a little bit of damage to the machine. So make sure it's all taped down. Now it's very important to keep your material flat as possible. Okay. So, I don't know if you can see at the back here, okay. You can push this down, you've got a gap underneath the mill foot up, it's actually hitting the foot. Same down here at the front, okay. You've got a slight rise to the board. Now it might not look much, it might only be 0.1 millimetre, but you have to remember that you're only cutting through the copper surface, and that is only 0.1 millimetre. So if it is raised slightly high, you can start milling the top surface here, perfectly fine. It's quite higher. When it gets over here, it's a little bit lower, okay, where it's flush to the backboard, and it's not going to mill, so you set your height over here. So always make sure that your board is as flat as possible, and tape it down in the areas where you're particularly bad. Normally that's the corners and the edges. So, yeah. So our board is all taped down and in place, it's not going anywhere, it's pinned. We're ready to initialise our milling machine. Okay? If your board hasn't got any these holes, the pin sizes are 125 thou, okay, working imperial, okay, and this one's messed up the drill, okay, and there we have it, that's our 125. We use that to make the holes. If you make the holes the same size as the pins, everything fits nice and snug. That's how we want it. Now then, where do we place it on the material? We want our circuit board to be conservative, okay, we don't want to waste material, so I'm going to place it, say, down here, next to this little cutout that I've already done, this little PCB here, that I've chopped out, and make it just below here, okay, it's only a small one, it won't take us too long. How do we place it there? Well, we place it there, same way as we do in our software, okay, so, at the moment we're zoomed all the way into this PCB, so you can't see the outside area, so if we zoom out, okay, here we are. This is our bed, okay, that's our design. So at the moment it's positioned somewhere just here, okay. So just on the above our centre line. You can tell where the centre line is because we've got two circles. You've got one here. This is our alignment pin back here, okay, and a little circle further back. This is our origin. Okay, which everything's actually measured to. So if you move your mouse over that, you can actually see it's almost 0, 0 on the screen. Okay, so that's our origin. That's what we measure everything to. Zoom out. Alright, here we are. Okay, so that's our board. We want to place it somewhere down here. Okay, so somewhere around here. See, it's on the screen down here. So we get our ruler, okay, got the steel rule, we are nice, so if we measure from the bottom corner, this back edge here, we want to place it close to this PCB, where we had this PCB, okay, so we want to measure this back corner, and we want to move this one somewhere down, where the back corner should be, so it should be roughly about, I don't know, 13 centimetres down, so I want to leave a little bit of room. I want to go about 22 centimetres along. So make sure that all your layers are in edit, okay, if they're not, right click and say edit all. Box round a lot, select the lot, we'll zoom in a little bit, say to there, so that we can place it a little bit more accurately. Okay. Grab it somewhere around, grab the board. There we go. Okay, so we've got our board. All of these X-pies down here, this is all to our origin, so we can move roughly around a corner. So we can move it down to about 20 along, 10 down. As you notice, I am in mils, so I want to change that to millimetres. So roughly about, there we go, 25, 12 down, yeah, somewhere around there, it's good enough. Okay, so that's where we want to place our board. So we're ready to start processing this PCB. Now, this is the top side of my PCB, okay, surface mount, so I don't need to flip it because I'm not working on the bottom side. If this was a single-sided design and it was through hole and this copper was on the bottom side, I'd have to mirror this, okay. So just like you would do for etching, if you was working on the bottom side, you mirror your bottom side. So you make sure that you mirror this, okay, so that you're actually working on the bottom. So when you flip the board back and the copper's at the bottom, everything's around the right way, everything orientated correctly. But in this case, I don't have to mirror. If you do have to mirror, you've got the mirror function down here, okay, and then it gives you a little tooltip called mirror. The one next to it, this one's offset. If you did want to place this board a little bit more accurately, you can use the offset function, and you can click on that. Probably not, because I haven't got the machine initialized. So yeah, can do an offset to set values and so on. There's the mirror. So as you can see, if you hit the mirror, it flips it, so you're working on the opposite side. Flip it back, it flips it to the top, because we've placed it down here. If you flip the material, okay, what was here is now up here, so it actually mirrors it to the top, so there's no shifting about. Okay, it does mirror it around the centre line, but I don't have to mirror in this case because it's a working on the top side. Now then, so working down here, what we need to do, we need to initialise our milling machine. So switch everything on, switch the speed controller on, switch the vacuum on, switch the control box on, and everything plugs into, and we initialise. And what will happen is the program will shift the mill head all the way across to here, okay, to the right hand side. It will juggle it a few times to make sure that it is at its maximum. It'll bring it all the way forwards, same thing down here, so it's maximum, and it will count back until it gets to its origin. So it zeroes the head, it sets its home position. The head knows, if the machine knows where 0 is, then all our measurements, just like our curve with X and Y, is all taken from the origin. It knows exactly where everything is. It is quite accurate. Come on, hurry up. It's so slow doing this bit. But it needs to be. Raise it forwards. Okay. And there we go. And here we have it. Milling head. Everything's all centred, and as you can see, the milling head here, the chuck, is slightly proud of the, slightly back away from the alignment pin. That's because 0 hole, which I showed you back here, our alignment hole is back here, our origin alignment. Okay, so that's all set up. What we can do is do right click on the bed now, because our milling machine is active, and we can go down to machine and we can jump to cursor. And what I suggest you do is jump to cursor on the corners of your PCB design, jump to cursor, and it moves the mill head, okay, to where your corners of your design are, so you can see exactly where it's going to sit on the board. Okay, so just like I said, 22 back, roughly 13 back. It's slightly beyond our previous one. It's to the bottom corner down here, and we said it was. And if you jump the cursor to various other areas, oops, that was a mistake on my part. I did jump to mirror the cursor. I think. Let's try it again. Yeah. Oh, bloody hell! Alright. Reinitialize. Not too sure if it was me or if that was a bug in the software then. That was into the wrong place. Yeah. Little hiccups like this do happen on CNCs. They're not infallible, but just like etching isn't infallible, CNC isn't infallible either. But once it is on the go, it is on the go. Okay, so again we can do machine, jump to cursor, it's just there, let's try and jump it up there, machine jumps up, cursor. This isn't right. What's going on? Something peculiar is happening here. Whoever used this looks like they've really done the job on it. It might turn into a debugging thing. Alright then. It looks like that the X and Y is switched. Why is it doing that? I do not know. Let's have a look. We'll do a jog. Okay, so jogging the minus Y, which is should be that direction. Y is in that one. X is there. Minus X. Continuous. That looks right. Yes. That looks okay. Yep, everything looks okay now, so why is it doing it in that corner? Let's have a check now. It's always good to run through this. That's our top right hand, bottom right hand. Bottom left hand, and top left hand side fingers. And there we go, it's working properly now, and as you can see, it's going to fit onto the baseboard perfectly fine. I'm not too sure what happened there. It's all running okay, no problems there. Looks like they're a little bit buggy to start with. Friday morning, no one likes Friday mornings. Right then, moving machines don't like Fridays, they can't wait till the weekend. Right, so circuit board is all placed down here. It's going to be cut down in this position on this board. Okay, so what we need to do is to start giving it some information, some tooling information. Zoom into this. Drill holes, you don't need to touch the drill holes, okay? The drill hole NC drill file is already in the correct format for this machine to start working with it. Brilliant, you don't need to touch it. So you can hide that one for the time being. Okay, that just leaves us with a board outline and our top copper. So you can view our board outline, because we don't particularly want to edit our board outline or do anything with it. We're just interested in doing the top copper. Okay, and what we want to do is get the machine to generate our isolations. And what that means is we tell it a particular size tool to use, okay, whether it's an end mill or a T cutter or a T8 or whatever you want to call it, a universal cutter. Okay, end mills and T8s, let's say, for this machine. And what you do is you tell them the software, right, I want to use a 31 thou mill, and I want it to isolate all of my top copper. And what it will do is it will generate a tool path around the outside edge of your copper that you want to keep. Okay, so it will remove any copper outside, okay, and it will isolate the track that you want to keep, the copper that you want to keep, from the copper that you don't want to keep. Okay, so that's what an isolation is. It isolates this track, okay, and it does it for every single track, every single pad. Wherever you've got pad, it will isolate around like a 31 thou. And you do that by selecting isolate. Now we want to set our tools. Now we work in thous in this, in mils. You check that back. There we go, we're working in mils. Okay, then so we start off with a right, we're going to use a T8 for this. I'll show you how to set up a T8. Okay, because we're going to be using end mills in this as well, and this point is doing it all in end mills. So we'll do a T8 tool, and we're going to say I'm going to set it out to do a cut of, let's say, I don't know, 10 thou. Okay, 10 thou, 0.254 millimeters. Okay, 10,000th of an inch. Next tool up that I'm going to use is a 31, and the next one is a 62.5 thou. 62.5 thou. Okay, so they're the tools that I'm going to use. What I want to do is select and remove redundant data, so that when it processes these tools, wherever a 10 thou, wherever a 625 can go, a 31 doesn't have to cut. Wherever a 31 goes, a 10 thou can go as well. It won't cut the 10 thou, it will only cut the 31, and so on. So it only cuts in the areas where the tool fits. Okay. The reason why it does that is because we want to reduce down tool life. It's pointless doing a cut of a 10 thou on an area, say down this track here, down the side of this track here, if a 31 will do that particular job as well. Okay, so it's a bit like it's pointless cutting at 10,000 and cutting at 31 and cutting at 625. You're doing the same cut 3 times. Okay, it's all against this track, and you know, what's the point? So you remove redundant data, and that's what it does. So it only mills in the areas where these tools fit. So the 10 thou will only go around the surface mount pad, probably. The 31, it'll maybe dip into the areas in between pads where the 625 can't, and the 625 will clear out the majority of it. So you set your tools, you do remove redundant data, expand on pads. What this does is you can actually get the tool to increase the gap around pads. So if you want to leave any copper behind, you know, you just want to isolate it or insulate, but you want to expand on pads to make solving a bit easier, you can do that and leave copper behind if you want. Doesn't really matter too much. Normally I'll say don't expand, and we just remove the lot because what you see is what you want at the end of the day, and what you see is what you get. Next one down, isolate select area. You only use this if you're going to select a particular area, so you would highlight particular tracks and you say just mill that particular area. Okay, but usually you want to do the entire board. Force isolation, that's a dangerous one to use. Force isolation, what this does is it forces tools into areas where it wouldn't normally fit. So say if you've got a gap of say 11 thou, and you've only got a 13 thou tool, with force isolation it will force that 13 thou into that gap of 10 in order to isolate the track. But by doing that you will scrub out copper. So be very careful when you force isolation. See, it even says that it may destroy data. Can be a problem one. Don't touch it if you don't have to. Always run the isolations with that unselected first. Only use it in dire circumstances where your tools don't fit, but they come very, very close to fitting. Okay, 1 thou, 2 thou, you know, okay. If you're out by, you know, 5 thou, something like that, you definitely want to leave it alone. 3 thou, leave it alone, especially around surface mount where you've got thin tracks. So we set our tools, we've done remove redundant data, and we want to isolate the top layer. So we select top layer and isolate. And off it goes, chugging away. It does 10 isolation, 31, okay, and so on. Remove redundant data, which is all it has done. It does a 625, remove redundant 31, and here we have it. Okay, so it just runs the 10s in between and around pads, does the 31 just up and down here, and the 625 around the outside edge. It's all colour coded, all down here. And the thickness of these tracks are actually relative to the thickness of the tool. Okay, so you can actually see where it's going to work and cut. And what I can do is if I hide all these, see the just view the 11. There we go. This is where the 11 is going to cut only. Hide that one. View the 31. That's where the 31 thou is going to cut. As you can see, it only uses the particular tool in particular areas which is actually needed. And that's really, really good. Because one, it speeds up the milling, because it doesn't repeat steps. And 2, it saves on tool life, because it's only using the tools as and when it needs to use them. So let's get rid of that, right click, view all. Okay, so it's isolated all well. Like I said, you can leave this copper, where this white area is, it's going to leave copper. Okay, so it doesn't really matter too much if you leave that, because it's actually insulated or isolated the copper tracks. But in this case we're going to use a rub, which is down here, and rubbing uses the last tool in your tool list. If you draw a box, okay, it actually, if I edit, make sure that you've got edit switched on, draw a box around and edit, it will run that large tool and it will clear out remaining copper. And there we go. So that's our board all isolated, all drill holes are in there. There's only one thing left to do, and that is do our board outline. Now I've cut the board outline with a 62 to tool size of 62. Don't bother removing redundant data because it's the only data there. We select our board outline and we do isolate. And what to do, I'll run the 62 contour router. Use contour router for chopping out boards, like I said before. And what will happen is it will do an inside and an outside. It does an inside because it's not a filled shape. If we hide all this, we just view that one. There we go. You can see your board outline there. It does it on the inside edge of this outline and the outside edge because it is a line. You've got two sides to a line. So just select your well, actually I should have said this before, but you can edit these isolations if you want. You can select things that you don't want to cut and things that you want to cut. And here we have it. We have our outside edge. Now the trouble with this is, if you try and chop this out of the board as it is, okay, what will happen is once you clear down this side and you clear out the area, this board is free. It's no longer held in place. It's not attached to this material, so it can slip, it can fly off the board, it can get pulled up into the chuck. Okay, very bad thing to do. What I suggest you do is down here you've got clip segments and what have you. You can select clip. You can actually clip out the area of this board. Okay, so you can do some tags on the board to keep it in place, and breakout tabs. Okay. So now the part will just go around the outside edge there, and it will lift the tool, won't cut in that area or in that area, and it will do the bottom bit. Okay, so the board is firmly fixed into the material, and all that you've got to do is push it out at the end, just break it out. So here we have it. This is our board completely isolated, drill holes all done and everything. What we've got to do is tell the machine to do that. So what I should do first is save this, save your work in case anything happens, and we run our first layer. But before I do that, let's get the tool into the tool and the head all set up. Because what we want to do, take a look at this here, this mill head. It's very important that it sets up properly. So I'm zoom into this. So we've got the anatomy of our, there we go, right then. So we've got our chucks down here, what we've got our tools into. You fit your tools into the chuck, you open and close it by using this up here, this section, okay? Push down the knob at the back, okay? Well, let me, can be a bit tricky, there we go, push it down, okay? That engages your chuck head with the opener, and you can open and close the chuck head. Okay. You can insert your tools. Over here, this is our solenoid. Okay, this is what actually controls the up-down motion. Okay, so you use this to set. You set this to various heights. Okay, depending on how high or how low the tool is set to cut into the material. Over here. This sets our maximum and minimum throw on the mill head, okay? How far it can travel up and down, its maximum, okay? And you do that, and you set this relative to the material that you're using, the thickness of the material, because you don't want the mill head to go all the way down and risk hitting the steel bed. That's bad news, because it's expensive to replace. All that you want to do is just set it so that the tool just cut through to the baseboard. Okay, another one, okay, you've got this, that's what controls the knob at the bottom. Knobs at the top control how high the mill head is off the board, and you want the height to be adjusted so that the mill is, or your contour or your drill bits are hovering just above this material. We'll set that in a moment. This knob here controls the foot height, the pressure foot. Okay. This, when the mill head goes down, okay, all the forces are resting on this foot, and it's this foot that actually gauges how far you're actually cutting into the material. So the further up this foot goes, the further down the mill head is allowed to travel until it hits this stop. Okay, this is its, what we call an emergency brake, if you like. It doesn't go beyond to this, but it'll go down to the foot. Okay, the foot serves two purposes. One, it controls, like I said, cut depths, the other purpose of it is that it pushes down on this material and it keeps it as flat to the board as possible. Okay, it's really, really important. Okay, because you don't want the material bending up or bowing or walking out of position. You know, you don't want any curvature to the board in any direction. You want it to be flat, and the pressure foot will do that. So when this is down, it will keep the board flush to the board, flush to your backboard. It's basically the mill head. So, first thing that you do when you do a PCB is drill the holes. So, we do a tool change. Okay, just do a tool change. So that just brings the head to the front. Okay, did I really want to do that? No, I didn't. No, so I don't even know what tool that I want to do. So right, cancel that. Mill. You want to run a layer. So we want to drill these holes. I'm getting ahead of myself right now. So we want to select this one, this through hole, a through hole.drl. This is our drill layer. Like I said, you don't have to do anything with the drill layer. You can run that, and it pops up with our next window. Okay, it says insert a 35.4 mil tool. Well, unfortunately, I don't have a 35 body mil tool, but I've got one close. It's a 39. It's, you know, it's a hole. It's going to be out by 0.2. 2 mils on either side. It's not a great deal. It's not a big deal to go through. So push down on your release. Okay, tool into the bottom. Make sure it goes all the way to the top. Tighten it up, and you pull up to engage the head. So when you turn this, it's not going to spin like it. It's very important that this is pulled up after you've inserted the tool, because you can damage the motor. Okay, because as it spins around, it's going to spin this head and it's going to wear down really, really quickly, and it's a new motor for you. So we've got our drill bit in here, and what we want to do, okay, skip this first. Do we? No, we won't. We'll go straight into it. What the hell? Okay, what we want to do first is to set the height of this foot so that the drill bit goes through this material. So what I suggest you grab a little bit of this PCB material. What do that, move this forward a little bit. You can't see anything, can you? What I'm talking about. Correct. Okay, back. Right, so we'll do this again, okay? Okay, like I said, you push down on your tool, okay? Down here, this is our little chuck down here. You put your tool inside, all the way to the top, okay? So that you think you can't push it back anymore. Tighten up the chuck, release the top, okay? Your tool's in there, okay? And this foot here, okay? At the moment, it's almost level with this tool, so you have to raise the foot in order for the tool to go through your board. So I have got another piece of material here. Place this to the bottom of your foot. Spin your depth wheel until you can see that. Okay, it's goes just past your board. Now you can run your finger underneath. Make sure that the tip of the drill is clearing the board, so that you know exactly if it goes through this board, it's going to go through this board. This is the same thickness, okay? It's the same thickness of the board. Next thing that you need to do, raise your solenoid, okay? The head of the solenoid, you want to unscrew it, okay? So, actually, we need to look at that. Just get a little more. There we go. So you want to raise this wheel here, okay? So that you've got a nice big throw on the machine. So that way it will go through the board. Okay. And as you can see, when I push down on this, it's actually stopping on this board. So it's not going to actually go through and damage this base. Okay, it's only going to go through and mill this. So this is set to the height of the material just into the baseboard. We've got our solenoid set. This is all set. Our foot's height is set, so it's going to drill through. next up is setting our speed. Now this is set to 43,000 RPM, so our cutting speed. For a 39th out, anywhere up around that value should be okay to cut your board to drill with. The thinner the drill bits, the faster you want to cut. Medium-sized drill bits you can slow them down. The larger drill bits, okay, the 78.7 and 125s, I'll suggest that you do run these a little bit quicker, because they do tend to skid on the surface of the copper, because there's not a lot of pressure behind them. So spin it up really fast so it bites that top, and instead of doing it slow and putting a little bit of force behind initially. This is our RPM to set. You can't change the inches per minute. This is our traverse speed. Okay, simply is that we're not traversing the head. Okay, you're drilling up and down. You're not milling, so this becomes redundant. But make sure that you've got drill bits set. You can use a contour router instead of a drill. Okay, if you do tick this box, okay, you do get the traverse speed up. Make sure that you do change the cut rate first. Okay, so you want to increase this a little bit. Switch this on. Traverse speed, you want to knock it down to about 15 or 10 inches per minute, and change your tool size. Hit OK, and it will use the contour router. As long as the contour router is below your tool size, it will use it to actually mill out that hole to the precise size. But in this case, I'm just going to use the 39 because it's close enough. So it's set to switch off this, drill bit selected, everything selected here, and OK. It's a little bit noisy, but as you can see, okay, it's moving across and it's going to start drilling down into the material. As you can see over here, so it's drilling down as far as the foot. Run out of power. Typical. Alright, I got it plugged in this time, so hopefully you'll see what's going on. Right then, so we've just finished drilling out this board. You want your air dust, don't you? You just want to blow off the excess that it didn't get sucked up. So all our holes are all drilled, so yeah. Let's move our drill head back. There we go. And I don't know if you can see that too clear. There you go. You can just about see along here our drill holes have all been drilled. That's all lovely. Alright then. Next thing that we have to do is start doing our isolations. So. Now, I'm going to be close to this because we have to see the head. What we actually do is setting our T8s and our end mills. So the next thing that we do is we're going to move on and we're going to start milling the board. Now, first tool, you work with the smallest tool up. Our first tool is the end mill. Okay, so this one down here. Okay, not the end mill, the T8. So we'll insert the T8 into the machine. So we want to do a tool change. You don't do a run layer. Make sure it is a tool change. You want to change the tool, and you want to set the tool's cut depth and etc. Right, we'll do that now. Right then. Mill all the way to the front. Down, untwist this, hand underneath to catch the tool, and there we go. So you just want to clean off the crap at the end of this bit, okay, so it doesn't collect, and puts it back into there. T8 goes into, okay, we'll close this up, right, and onto the board. Okay, so we've done a tool change. And what you want to do is a test cut. So bring your mill head to the front of the board. Okay, somewhere around here. And we want to set up set the pressure foot so that the tool only just bites into the surface of the copper. So lower your foot first. Okay, past the mill. And push down on the top. You can see that it's not at the end mill, that the T8's not going to hit the board. Reduce your solenoid, so screw this in so you get a nice bit of force behind the solenoid when it's going to be cutting the board. You want to go up to jog tool. So let's jog it into a reasonable position to start on that test cut. Somewhere there will be okay. The foot is fully on the material. Okay, so we want to set our speed to 60,000 RPM and the jog speed is say roughly about 10. No, we should be able to get away with 15. And so spindle on. Jog, this is all under the jog menu. Spin on first, wait for it to come up to speed, head down, and you want to make sure that you've got continuous set. So what you want to do first is to lower the tool, so you start biting the copper, about there, and then to jog the tool back and forth so you can see it start to cut into the board. Cutting there, a little bit deeper, and there we go, head up, spindle off, and we're going to just jog the head out of the way. Okay, so we've got a cut just here, okay, it's just gone through the material. And you want to make sure that you want to be able to tell whether or not it's cut wide enough. So what we use is one of these. Okay, it's a magnifier with a built-in measuring gauge. Okay, so you place this on your board. Okay, look through it. Okay, line it up with a gauge and take a rough measurement of the cut. So this is cutting at about 0.2 millimeters, just under 0.2 millimeters. This is cutting just under 0.2, so I want to go a little bit deeper. 0.2. What is it? No, 0.2 millimeters. Is less than 10 mils. 10 mil or 10 thou is 0.25, roughly around 0.25. So bring the head back, and we do another test cut. Okay, so spindle on, head down, and we want to go that little bit deeper. Cutting a small little groove in the board, head up, spindle off. Okay, so lift the head back up, spindle shut down again. I don't know if you can hear me over this, it is quite a noisy machine. Okay, we'll jog this back in the X direction. Okay, so we've got another cut here. So you can actually see this a bit better. Right. Okay, so we've got two cuts here. Okay, this is our first one at the bottom. Okay, the one at the top, you can see it's a little bit more wider. That's because we cut deeper on the tool. Okay, now we're going to remeasure that one and see how we go. So measure it back on, and just line it up, and this time it is cutting at about 0.25. Excellent. Okay, there's a bit of luck. Let's get that on the second one. Okay, so we've set the cut depth for the T8. It's going to cut our line width. So, as you cut deeper, the width gets wider because it's a triangular cut. You can close that. We can do mill. We can run layer now. The 10 thou. Okay, that's going to cut at 10 thou. Run. Always bring the tool to the front, so especially to put a tool in the insert tool. But I always find that it's always best to insert the tool and set it up before you actually start cutting. That way you know that it's going to cut through the material before you start doing the actual, before you do anything else. Always best to double check. Okay, so because this is quite a delicate tool, we're running it on the very, very tip of our T8. Okay, it can be quite fragile, so we want to reduce down the speed. Cut to say 15, okay, just like we did in the jog, and set our speed to 60,000 RPM because we want to cut very, very fast because it's quite a fine cut. Okay. In this case, well, we need to make sure I set it to a pointed tool first. Okay, it's a T cutter, 60,000 RPM, so it's traverse speed. This is how quickly the mill head's going to move backwards and forwards in the XY direction. Okay, and okay, and it will go off and mill our balls. We don't need to set the height or anything because we've already done that. So, okay. So it's only cutting in the areas. You can see on the screen, okay, you can see the blue area slowly highlighting in where it's cutting. Okay, I'll buzz through that, and then I'll stop the video. Okay, so we've done the 11th thou now. Now it's on to the end mills. Okay, now the end mills you don't have to measure the width of the cut. All you have to do is measure or observe to make sure they're actually cutting through the material. Okay, because they have a fixed width. So what we do our tool change as usual. Come out, T8's out, and the 31 goes in. And we'll screw that one in, and there we have it. Okay, 31 thou is in, because that's the next tool that we're going to use. Okay, we want to move that to a position, roughly around where we cut before. Save on material, so let's move that out here. Roughly around there. Move it onto the material. There we go. Right then, so set our jog speed up to 15 because it's a thick tool. It can be the maximum jog speed. Spindle speed about 49,000 RPM should do it. Should be okay for the 31 thou. So again, lower your foot, okay, and then bring the tool down so it's just above the material so that the foot hits before the tool does. You shouldn't have to adjust the solenoid or anything because that's already been set and everything else has been set. So spindle on and head down. What you want to do bites the top of the copper. So just biting the top of that, and just like before, jog it to make sure that it's touching to the top. It's not quite touching. It's just skimming the surface of the copper at the moment. Go a little bit deeper. And there we go, it's touching through the copper now quite nicely. Maybe a little bit deeper. There we go. So head up. There's a head up and spindle off. We'll jog this back. You'll probably be able to see this cut here now. Yeah, you can actually see that one on the camera all the way from back there. Okay. Let's cut through the surface of the copper nicely. And we do what we did before. So it's mill, run layer, top, and you do that one exactly the same for the 625 and the top rub out. So we'll buzz through this one on the quick. So run that one. It's an end mill, so make sure the end mill is set. 49,000, perfectly fine for the 31 pound drill bit. You don't want 60 inches per minute. That's the actual, that's quite a fast traverse speed. For the 31, say 25 inches per minute. Okay, and okay, off we go. Okay, so we've done all of this blue area here, the light blue, and now we're going to do this area. Removing all that excess copper that's going in between them. You can see this is quite it's a lot quicker than the previous one. Almost done one side already. shows you on how it's done. Like I said, you do exactly the same thing to the 625 tool. This is how quick it is to do. So, once you get used to changing tools, this is quite a quick process. See, it's doesn't take me too long to actually do. Again, move it back down to where he was doing all the test cutting. If you test cut in the same area, then you're more or less guaranteed to, to get a really good cut, a more uniform one throughout all the tools, rather than testing in different areas of the board. You only really need to test in different areas if you're going to be doing a huge board that's going to span the, quite a portion of the sheet. So again, this is a bigger tool, so the same settings apply. It's all cutting the board perfectly fine. Go to the board just like the previous ones, and you mill the run layer, the 625 run, same as before. So this one is going to be even quicker, so let's shift it back up to say 49,000, and we'll do it to say 35 inches per minute. So this is only going to take less than a minute to do. Done. Now, like I said before, it's up to you whether or not you want to remove the excess copper. For this particular board, I don't think that is really necessary, so I'm going to skip on to the contour route, and again we'll chop this board out. If you want to remove the copper, you can do the rub, you'd run layer, and you'd run through the same settings as the 625 tool. But we're going to skip over that, and then we're going to do the contour route. So just like setting the drill bit, exactly the same for the contour route. So run layer, board outline for the contour route, and run. You select contour router, we set a speed to say, I don't know, 50, you'll be fine anywhere around that region. Set it to say 15 inches per minute. Contour routing using the 62 out contour router, so router 62. Change the tool changing. There he goes. And use your test material, okay, to set the depth, just like you did with the drill bit. Okay, there we go, so it's just through the board. Okay, the tip is through. You can feel that on your finger. Increase your solenoid, so you're no longer milling on the surface. Okay, you want to go through the board, so you need the extra downward motion. All our bits are set here, and okay. Off we go. So this is a contour router. It cuts on the edge of the board, so it's going to punch through the board just like a drill bit, and then it's going to cut on the edge. Off it goes. Raises where the tabs are, where we cut the tabs out, so we've got a tab here, right, pull the tool up. Board has been cut out. Grab a air duster, okay, and clear off any junk that's on top. Inspect the work, and we can take it off the milling machine. So this is what we've been working on. Here it is. Okay, all nice and neat. As you can see, all the tracks are all isolated. Okay, there's some spurs in between the pads, but they can be removed with a scalpel. So let's take this off the machine, and here we go. So when you take the material off, make sure you go into the mill menu and you do material change. You use that if you're going to flip the material or take material off or put material on. Take off our masking tape. Okay. Because we had the tabs, this hasn't shifted, so it's nice and squarely cut. Get this out, quick, pull it out, and just got to tidy this board up. So, scalpel, okay, let's run it down the edges, clean up the burrs. Always use the knife away from you, okay, that way you're not going to do any damage. Now you've got these little divots at the end. You can chop these off with a pair of side cutters, or you can use the scalpel to trim them off if you want. Side cutters are a little bit more safer. And we have our board, it's all done. All that you need to do now is prep the board for soldering, so you might want to tin it, or you might want to flux it. You can get flux spray. Flux spray with conformal coating, so you can do both at the same time. Give it a spray, give it a tin, give it a spray, and there you go. It's all done. Okay, and make sure that you return to the head back to its home position when you're finished.